Sorry. There we go, finally. All right, so today we're going to continue with database stuff, but it's going to be in the context of programmatically connecting to your database using Java and in particular JDBC. Oops, sorry. There we go. All right, so make sure that all the design document iterations are up here. If you never picked up any of your previous iterations, please do so at the end of the day. For the next two labs, you're going to be working with JDBC. You're going to be working with JDBC in the context of deploying to what's called a Glassfish server, which is a Java application server. And so do make note that when you get to lab, you may or may not be able to use your own computer. If you've downloaded and installed Java J2E, the version of Eclipse, you're good to go. Matt Shanahan has graciously offered to school you through whether or not, if you're using IntelliJ, go see Matt and he'll show you how to deploy using IntelliJ and Tomcat. But when you get to lab on Wednesday and next week, we're recommending that you actually use the lab computers and log into the SUSE partition so that you can deploy locally. One way or the other, you're going to have to deploy. If you deploy manually through your Eclipse, just make sure that you're reading the instructions and make sure that you're on the same page with your partner for the next two labs. The goal for the next two labs, and the goal for today and maybe a little bit of Thursday, is to explore programmatically accessing databases. So when I run MySQL Workbench here, and I execute these queries and I show the tables, et cetera, I'm using basically an IDE. I'm kind of debugging, I'm kind of developing my database using this tool. But of course, in real applications, you don't have somebody sitting there at the keyboard 24/7 running queries, right? Instead, you want the application that you're running on a web application or an Android application or something. It's going to be making queries automatically through code to your database, pulling data. The user enters in data, and then it persists that data, saves that data to the database, etc. So most languages support some mechanism to do this. And in the context of Java, it's the Java Database Connectivity API, or JDBC for short. Okay. If you're working in another language, there's ODBC, which is Open Database Connectivity API. If you remember last semester when we were using C, one of the very last labs that we used was you were connecting to that video game database. We actually wrote all the ODBC code for you. If you want to go back and check that out and see how it's done in a different language, go ahead. Otherwise, every language supports some way of connecting to a database. And they all do so through an API. Hopefully you're familiar with this term already, but it stands for Application Programmer Interface. And the reason that it does it through an interface is because of that D in solid. Do you remember that? The solid principles, the 5 solid principles. The last one is dependency inversion. You don't want to write code that only connects to a MySQL database. You don't want to write code that only connects to a Postgres database. Because what happens when you come along a month from now and you realize, well, this MySQL isn't working anymore, or Oracle is going to start charging us for it or something. We want to switch over to Postgres because it's cheaper, it's faster, whatever reasons you've got, right? If you've written thousands upon thousands of lines of code that are specific to MySQL, that means that you've got to throw it all away and redo it all for Postgres. What you want is dependency inversion, right? You don't want to depend on the underlying database. You want to only depend on a particular API, an interface, so that a particular vendor, like Oracle or Postgres, they will actually publish a driver that conforms to that API, but you've only written your code towards that API rather than a specific vendor. Meaning that it's decoupled. I don't know why it's so bad today, but let me move it over here. All right, it's probably connection, actually. Can you still hear me? Yeah, there we go. All right, so you don't want, you only want to program towards that interface because the interface doesn't change. If you want to change databases, you take this driver and you throw it away and you bring in a new driver. And the driver conforms to the interface rather than your code conforming to the driver. So this interface in between ensures that your code is generic and it will work with any database that publishes a driver, right? Again, you don't program towards a specific database. Instead, you use these very generic objects. We're only going to look at a small subset of them. I'm not even going to show you unprepared statements, and we'll look why later on. It's called an SQL injection attack. But JDBC provides these general things. A connection. A connection to what? A connection to a MySQL database? A connection to Postgres database? No, it's just a generic connection. A prepared statement. You prepare your statement that basically a query. It's a prepared query. You want to create a query that you can then send off to the database. You use a prepared statement. If you get results back from the database because you're selecting stuff out of it, you use a result set. All three of those elements are completely generic, and they're just in the API. Instead, what you do is you then bring in a specific driver for the database you are actually connecting to, right? And because you program towards this generic API, and the driver takes care of all the actual functionality, you never have to change a line of your code if you're changing your database, okay? There are also something called ORMs, right, which are object relational mappings, right? For example, in the context of Java, JPA or Juke is another product that I've taken a look at, and it's kind of nice. But JPA is the de facto standard. It stands for Java Persistence API. It's just a more generic API built on top of it where you don't actually have to write any queries. It's a very nice thing. Instead, all you do is annotate your classes and say, this class is connected to this table over there. This variable in this class is connected to that column in that table over there. We're not going to go over it, but if you're interested, there is a bonus, that's not bonus as in bonus points. There's an extra lab 10.5 that covers this, and there's also a video in the online modules if you want to check those out. I run through how do you use JPA, and then you can run through it yourself with an extra lab if you're so interested. Otherwise, we're going to look at plain old school JDBC. So, demonstration. For the remainder of the day, I'm just going to show you how it works. I'll eventually be posting this code if you're interested, but otherwise, you'll see the exact same code tomorrow in your lab. Right? The first step is to download the driver. We're connecting to a MySQL database. Technically, we're connecting to a MariaDB database, but they're more or less compatible. So we're going to go to dev.mysql.com, which is basically an Oracle website, and we're going to download the actual driver, which is just a jar file. Right? So, I can click on here. Right? So when you go to download this, of course, it'll say, which operating system? Don't worry about that. Select the platform independent. It's Java. Java is cross-platform. I don't even know why they asked that question. You can either choose a tarball or a zip. Let me go ahead and download the zip. Right. And by the way, it wants you to sign up. Forget that. Just no thanks. Start my download. All right. And here's the zip file. I'll open it up. There are the contents. The only thing that you care about, though, is that jar file right there. Okay. So before you've all done this now. You've imported a jar file. The instructions are in the handouts as well. But I'm going to what I've done here is I've prepared a little bit. I've created a film class and a director class. The director class has a director ID, a first name, and a last name. Sound familiar, right? This is the database that we designed last week, or 2 weeks ago now, I guess. The film has a film ID, a title, and a director, right? Which is an actual object. It doesn't have a director ID, which is what the database would have, but it has a reference to it, okay? Let me come over here and show you these tables again. Remember, we had the actor table, a director table. One director can direct multiple films. We've got a film and then film actor. That's a join table in between because one film can have many actors and one actor can act in many films. We're going to focus on actor and director here. When I describe film, remember that it has this primary key, film ID, title. We also designed it with release date, gross earnings, and a bunch of other stuff. I don't want to do everything here. I just want to do a small subset to show you how JDBC works. Of course, if you wanted to capture all of these things in your Java class, you would. And by the way, look at the names. Film ID, camel cased, lower camel cased, title, and director ID, all camel casing, right? Or lower camel casing. That's why I follow that convention in my databases, because I'm going to be naming those variables exactly the same thing in my Java classes. There's going to be generally a one-to-one correspondence between the things that you do in Java and the things that you are persisting to your database. So that's why I like to follow this more modern naming convention. Okay? Let's see. So I need to download the connector J, I don't know, the connector J for Java. And here's the jar file. I'm simply going to drag and drop that jar file into my lib folder. Right? There we go. And copy it, yes, whatever. And then I'm going to add it to my build path. Build path, add to build path. If you want to, you can also do this through a Maven dependency. That's not something I cover in this course, but that's what I did prior to this so that you don't have to download your own stuff. If you're interested in Maven, come and talk to me. Otherwise, there are plenty of tutorials out there. Maven is a dependency management system where if you say, my project has a dependency on that jar file over there, JSON, I use JSON, I use Xstream, I use MySQL, I use another library to do CSV processing or whatever, right? You've been downloading them manually and adding them to your project. You've been doing your own dependency management, which is perfectly fine. I don't want to get into it because it's yet one more thing to cover. But if you're going to do this in practice, you would use a dependency management system like Maven, in which case you would say, I depend on that thing over there. It automatically downloads it and puts it into your project. And if there are any updates, like you want to upgrade to the newest version, you just change the version and it automatically goes and gets it. And the great thing about dependency management systems is that if you want this jar file, and it depends on 10 other jar files, and those 10 jar files depend on 5 other jar files, it automatically goes out and gets that entire dependency tree for you. Right? So it's a nice little tool, but it's beyond the scope of this course. Yeah, the NPM would be the node package manager. Basically, you download dependencies. Everything is going to have a dependency management system, even your operating system. I use ports. I've got a Mac, but I use ports. Mac ports. The other one that maybe I should start switching over to is what? Mac people? How do you download stuff from the command line? No? Nobody's done that? All right, I forget what it is, but there's a more modern version of it. I still use ports, though, Mac ports. So now that I've got it in my project here, I can actually start using it. What we're going to do then is we're going to connect to our films database. And we're going to process film and director data. And then I'm going to also show you how to create a new film, maybe a new director, and insert those into the database. Just so that we know whether or not this works, let me go ahead and see what we put in our database here. Right? If I select everything from film, right, then I see, oh, there's Dune and Deadpool in there right now. So if I'm successful in connecting to it through Java, we should see those 2 films there. And everything from director looks like David Lynch and Tim Miller, the 2 directors of those 2 movies. Okay, so that's what I'm going to be expecting. Right? Those are the test cases that I've set up, and so that when I write this program and execute it, those are the test cases I should see printed out. Okay. So I'm just going to do all of this in a main, right? Public static void main string args. Right? And of course, you would want to build your own API. If you want to create a function that goes out and gets a particular film by their ID or gets all the films, right? Then you can do that as well. In fact, let's do it that way instead. Let me go ahead and create a function that I'd really like. I'd really like a list of all the films. So a list of film objects get all films, right? And that's where we'll put all our stuff. Okay. And then in the main, when I actually execute this, I'll go ahead and just say a list of films is equal to get all films. And I'll have to make this static, by the way. There we go. Get all films. And then for film F in films, system.out.println F. There we go. So that's my test driver right here. I'm just going to get all of the films. We've got to import list. There we go. I'm going to get all the films, all their data, and just dump it to the standard output to see if I can make a connection to the database and get things working. Okay. All right, so there is actually a 5-step process to this. I'll walk you through each one of these steps. The first step is that you need load the driver, right? The JDBC driver. Okay. This is necessary because again, you could potentially be connecting to a MySQL database. You could potentially be connecting to a Postgres database. So how does the API know which driver to use? You have to tell it which driver to use. Now there are other ways of doing this, but the easiest way that you're going to want to do it is just to use the following code. And let me go ahead and just cut and paste that. There we go. Oops. There we go. All right. So there's a class.forName. That's a reflection thing. All right, we'll get to the issue here in a second here. But basically, you're saying load up the JDBC driver class. And the driver class, you need to provide that as a string. So let me go up here and create a string, driver class. And for your purposes, your driver class is going to be as follows. If you use the latest JDBC connector, if you're watching the videos, I'm using an older JDBC connector, I think version 5. Here you might have seen that I was using version 8. You can't see it very well, but it's 8.01 something, what is it? 8.15. So major version is 8. So when I switched over to 8 in preparation for this class, apparently they changed the package that everything was in. So com.mysql.cj, I have no idea what that's for, jdbc.driver, right? And that's the driver class that you need to create a new instance of. And now Java just knows that you're connecting, that you're going to use that class as your driver so that you connect to a MySQL instance. Again, it's MariaDB technically, but it's all the same for our purposes. Okay? You'll note here that there are a lot of different exceptions thrown. They're all checked exceptions. Do you remember the difference between a checked exception and an unchecked exception? A checked exception, you have to surround it with a try-catch. So to deal with that, I'm doing a catch and release. Right? You catch the fish, and then you're not actually going to eat it, so you just release it. The way that I release it is I just rethrow it as a runtime exception, an unchecked exception, so that now you don't have to surround, down here in the main, you don't have to surround this get all films with a try-catch anymore. Okay? And unfortunately, that is an artifact of the fact that JDBC is actually very old. It dates back to Java 2, so 1997 or something like that, whenever it was. And they still thought checked exceptions were a good idea. And unfortunately, they're not, because you have to clutter your code with all these try catches. Yeah. You could. I could simplify all of this. The suggestion is, couldn't you just use a generic exception? And yes, you could. Right? If you want more fine-grained behavior, though, where you're going to do something different in each one of these things, then you would have to have all three. Right? All right. Or you could do something like this. I think that the syntax is or illegal access exception, right? Yeah, so you can enumerate them all up here. Now, of course, this is dead code because you would have caught it up here, and I won't do that. Right? Okay, so that's step 1. Step 2 is create the connection to your database. Right? So I'm going to create a connection. I'll just call it con. You can call it C, whatever you want. And initially, it's going to be null. Let me go ahead and import this now. Now you'll see here that there might be several options. Like because I put that driver class into my my build path, it might think, well, do you mean the API connection, or do you mean the connection that's provided by the driver? I mean the API connection, because if I start writing my code towards that particular driver, that means that I'm not conforming to the API anymore, right? I've thrown out that dependency inversion altogether. And now I'm only writing towards one particular database rather than just generic any old database, right? So the one that you want is java.sql. Everything that you're going to want is java.sql.connection, java.sql.resultset, java.sql.whatever, right? Okay, well that doesn't create the connection, but the following does. Again, I'm going to have to surround this with a try catch. I'm going to call the driver manager, right, that I registered that driver with, and I'm going to ask it to give me a connection, get connection. You'll see immediately here that it needs a URL, a user, and a password, right? So up here, I'm going to go ahead and add those. String URL equals something. String user is equal to me, right? And, right, yeah, I'm going to connect to my database. And my password, right? So remember when I told you don't use the same password that you use on anything else? Because eventually it's going to appear in your Java code and you're going to share it with your partner. And the TAs when they go, and the LAs when they go to grade it, they're going to see your password, right? Because I'm going to be storing it in plain text here, just for 156, right? That's my password. Don't anybody screw with it right now. Otherwise, we'll be dead in the water here. For 5 or 10 minutes. I'm going to be putting my password plain text into code. Generally, you don't want to do this. In real life, in a real project, you would not embed your password into your code. You would put it, at the very least, you would put it into a configuration file that is not checked in with your regular code base. One of the most fruitful avenues of attacks right now is that people checking stuff into a public GitHub repo. And you can very easily write scripts that just scrape GitHub repos for passwords. And once you've found a password, great, you're in, right? So we don't want to check plain text passwords into a public repo. The workaround there is that you put it into a configuration file that is then deployed, that is separate from your code base and is deployed separately. Or even better yet, you use what's called a data source. A data source, when you set up an application server or when you set up a database server, what you can do is you can set up a data source so that when you start up the server, it prompts you for a password. You enter the password, and then it's stored off, only in memory, though. It never exists in a source file. It never exists in a configuration file. It never exists except for in memory. And then if the server dies or if the server is shut down, the memory is wiped and it's gone. And then next time you start it up, you still have to enter in the password again. That's how data sources work. Okay? That's what you would do in practice. But for this course, you're not holding any sensitive information here. You can go ahead and just put your password right directly into your source file. All right, and so now I've got the URL, or no, I don't have the URL. That's another quirk. If you're watching the videos, you'll get one URL. If you are using a more modern JDBC connector J, version 8, you have to use the super long URL, right? This is the workaround that I had to find for everything. It's you're connecting to a JDBC MySQL on csc.unl.edu. Obviously, you're not going to connect to my database, so you would change that. And then use Unicode true, use JDBC compliant time zone shift, blah, 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 all this stuff, because I ran into a bunch of time zone shifting issues on CSE. So when this code gets posted, you'll be able to use this. In lab, I believe that the connector is already provided, and it's an old school connector. It's a version 5 connector. You won't need to make any updates. But if you use version 8, you're going to have to use this URL as a workaround. Okay? Great, I've got my connection. Again, it's going to be throwing a generic SQL exception, and I'll just call it E here, which I'm going to rethrow, throw new runtime exception. I'll wrap it up E. Right? Now, here's where I get to indict the designers of checked exceptions. If you look at the documentation in Java of why they created checked exceptions, remember, are things that you have to surround with a try-catch. If I didn't surround this with a try-catch, it would be a syntax error and it wouldn't compile. If you look at their own documentation, they say, when should you use a checked exception? You should use a checked exception when you can reasonably recover from the error and move on. What would happen? Under what situations would we have an SQL exception here? The URL, maybe we don't have a network connection. How can you reasonably recover from a no network connection in a Java program? You can't. You've got a bad password. How can you reasonably recover from a bad password? You can prompt again for it, but again, we're not doing an interactive program here. So their very own design principles speak against using checked exceptions, at least in the context of SQL. SQL exception, first of all, everything that comes out of JDBC is going to be just an SQL exception. There's no like a wrong password exception. There's no network connectivity exception. There's just SQL exception. And we're forced to surround everything with a try-catch because of it. Right? 20 years later now, we're still living with this because of their poor decisions back then. By the way, if you are interested in JPA, I mentioned it up at the front, JPA solves all these problems by not using any checked exceptions whatsoever. So you don't have to use any try-catches. Right? Okay, that's step process. So we loaded the driver. We've got our connection. Now we need to actually do something with our connection. So what we're going to do is we're going to prepare and create our query. Right? So I'm going to need a few things here first. I'm going to need a list of films, right? Because that's films is equal to new array list of films. And in fact, maybe I should put that at the top. Here we go. I'll put this at the top because that's the thing that I'm going to actually return later on. So down here at the very end, return films. Right? And now all my syntax errors go away. But now I'll need to prepare my query. Well, first of all, I need to write my query. So string, I'll just call it Q for now. You might be able to come up with a better name, query, right? And now it's just a string. I'm going to put in my query that queries out all the films. So select everything from film. Oops, film. That's good enough for now. You can put a semicolon inside if you want to. It's not necessary. Another note here, this is bad practice. We'll revisit that later because you are selecting everything. All I really care about here is, let's go ahead and describe the film here. All I really care about is that right now is the film ID, the title, and the director. But I'm also getting 1, 2, 3, 4 other pieces of data. I'm sending everything across the network, whether or not I want it or not, or use it or not. Right? That's why using star is a bad practice. You're wasting resources. You're asking for data that you ultimately ignore. Don't do that. Instead, we should do what? Select the film ID and the title for now. Right? And forget about the director for now. Okay? That's my query. The third thing to notice here is I went a little bit of a departure from what I was doing over here in MySQL Workbench. MySQL Workbench here, I was using lowercase, right? That's because I've got, for whatever reason it's not doing it right now, but I've got syntax highlighting. Maybe it's because I switched to dark mode, I'm not sure. But generally I have syntax highlighting. Uh-oh, do you see syntax highlighting within a string here? No, so that's why I'm using all uppercase, the old school way of doing this, because there is no syntax highlighting. Now, you can get syntax highlighting within strings. You just have to download like a plugin that does it for you, or you have to reconfigure your IDE to do that. All right, so there's my query. I'm going to need a couple of other things here. A prepared statement, I'll call it PS for now, and a result set, RS. Right? So the prepared statement, the prepared statement is actually going to be the prepared query that I'm going to execute. That's going to return a result set. The result set is the set of results from the database. Right? Oops, didn't want that. There we go. And I'm going to have to, of course, import these. Prepared statement. It's going to be java.sql prepared statement, java.sql result set. And you see that up here. See a lot of java.sql stuff now. Right? That's all part of the API. Okay? So what I need to do now is I need to try to surround this in a try-catch. And what I'm going to do is I'm going to prepare my statement. So I don't know, 3A, prepare the statement. So I'm going to do that with my connection. I'm going to ask the connection, please prepare my statement, and with this query, Q. Okay? And then when so now it's prepared. So 3b, I need to execute my the statement. And to do that, what do you think? Now I've got my statement q dot execute. No, it's dot. What is it? Prepared statement ps. Right? Sorry, I screwed up here. Preparing a statement returns a prepared statement, so I need to capture that. And then ps dot execute query. Well, that returns a result set. RS is equal to this. So I'm preparing the query, executing the query, and now I've got the result set in my hands here. Okay? And let me just go ahead and take care of this now so that syntax error goes away. There we go. Catching and releasing. So now I've got my result set. It's not a set as far as a traditional set, right? It's not like a set of films. Right? If it were a set of films, I'd be done by now, right? JDBC or JPA, you can actually do something like this. But a result set is just a generic, it's not even a set. It's just a set of results, right? If I execute this over here, it's basically this thing right here, except for I didn't select all the columns. I just selected the first two and the last one, the director. Just the first two, right? So my result set looks like this table right here. What I need to do is I need to iterate over that table and process each record. Right? If I gave you a table here, you'd start at the first record, then go on to the next record, then go on to the next record, next record, next record, until you are out of records. Right? So the pattern for doing that is a while loop. Right? While you still have records. The way that you both advance to the next record and check to see whether or not that record exists is rs.next. Okay. While you still have the next, this is kind of like how you use the scanner in some of your projects already. That you started. Give me the while it has the next. While it has another line, go ahead and go to the next line. Go to the next line. Go to the next line until you're at the end. You no longer have any more lines, and now you break out of the loop. Right? Before it even starts, the reason I'm using this pattern of rs.next is it returns true or false. Did it return a row? Did it return a record? Right? And before it even begins, it's before the first record. And that's why I put in the while loop rs.next. That first call immediately goes to the first record. Then on the next iteration of the while loop, it goes to the next record. Then on the next, it goes to the next record, next record, next record, until it gets to the last, after the last record, at which point it returns false. There are no more records, breaking me out of this while loop. Okay? All right. Well, within the while loop, I'm looking at one particular record. I want to now process that record by iterating. If I'm going over each row, then to process one individual record is going to be iterate over each column, right? And to do that, you can iterate over columns, but I know the two columns that I have here because of my select statement, film ID and title. Those are all that I care about, so I'm just going to get those directly. String film ID is equal to rs.get. Well, what is film ID again? What's its type? It's an integer, right? So I will get an int, right, of the film ID. Right? And what about the title? String title is equal to rs.get. Well, that's not an integer. What is it? It's a varchar in the database. What's a varchar in Java? String. Right? And it's called, what was it? Title. Right. There we go. And now I can print those out if I really want. Oops, what's wrong here? Int. What are you complaining? Oh, it's rightfully complaining about this. Duh. Right, there we go. And now I can realign these things. There we go. All right. So I just grab the film ID, I grab the title, and now I can actually create a new film. So film F is equal to new film of the film ID. I'm calling the constructor here and title. Right? And I think I've got that. Yep, it's. I built that before I came here because I knew that I was going to want to use those two things. Okay. All right. Good. And then once I've created that film, I can add it to the result. So films.add F. Right? Now, let me just go ahead and run this and see if it actually works, or if I screwed up somewhere. There, it works. Dune 1 and Deadpool 2, it's printing out the film ID here. Does that jive with what we actually have in the database? Yes. So, we're done. Pack it up, go home. No. If you open up a file and you read to it, or read from it, or write to it, what do? That's a three-step process. You open up the file, you process it, read or write, doing whatever you were going to do. What's the last step with the file I/O? You close it. This is even more expensive. Making a network connection to a database, doing authentication, doing that handshake protocol is actually quite expensive. And it's so expensive that the CSE server has actually throttled you down to at most 30 connections, 30 persistent connections. So if you take the if you just open up connection, open up connection, each one of them stays open for up to 5 minutes. I think that's the configuration on the CSE server. So if you open up 30 connections and then you want to open up and leave them all open, you don't close your resources and clean up after yourself. You try to make that 31st connection, it's not going to work because it's going to say, no, you have your maximum 30 connections. You can't have any more than that, because if you just asked for 1 million connections, that would take the server down and destroy it, right? So you are limited to 30 connections. Be good stewards of your resources. A database connection is actually very expensive to create, somewhat expensive to destroy, and certainly expensive to keep open and not use. Right? You're wasting resources. So, as a final step, step 5, close your resources. Right? There we go. I'm going to close everything. I'm going to, try. Again, I've got to surround everything with a try catch because that's JDBC. Give myself some more real estate here. There we go. All right. So I want to close the connection, certainly, but I have other things that are connected. I've got a result set. I've got a prepared statement, and I've got a connection. Right? All those things are potentially open. Okay? So I'm going to close them. In what order do you think I should close them, by the way? In reverse order, right? You open up A depends on B. You open up B depends on C. You open up C. Well, you'd better close them in the reverse order. So I'm going to go rs.close, right? ps.close, because that was the result set, the prepared statement, and finally con.close, the connection.close. Right? Now, that'll work. And if I execute this, it's happy about that. But there's a much better pattern to this. For example, you can check to avoid null pointer exceptions. For example, up here, if the connection failed, well, we would have rethrown this as a runtime exception anyway. But if the connection succeeded and then suddenly somebody kicked out our network connection, or the wireless dropped us or something like that, we would be in an intermediate state, and maybe that resource was never allocated. So a better way of doing this is check to see if it's null. If rs is not null, then it's safe to call one of its methods. And if it's not already closed, rs.is closed. There we go. If it's not closed, then you want to close it, right? Otherwise, if it's already closed, then there's no reason in closing it again, right? So that's the come on, can't type today. That's the pattern that you should probably follow. Let me go ahead and cut and paste that for the other two. PS, and PS, and con, and con. And that protects you from doubly closing resources and wasting resources to close things twice that you don't need to be closed. And that's perfectly fine. Right? It also avoids null pointer exceptions. If it's null, then it cannot be open, and or at least it might be open. It's just that you can't close it anyway. You'd result in a null pointer exception. So that's the standard way of closing stuff in reverse and doing null pointer checks and whether or not it's already closed. Now you'll note here that if we're going to do this also for directors, right? It's going to be a lot of cut and paste. Let me go ahead and cut and paste this stuff, in fact, all of this, and let me go over to that director class. What would it look like? What changes would I make? It's no longer a list of films, it's the list of directors, right? And get all, not films, but directors. There we go. Films, directors, right? But does any of this stuff change right here? No, I'm still making a connection to the same database. What principle am I violating here? DRY, don't repeat yourself. Maybe there's a way that I can take this code and put it into another class. A class that's responsible for creating connections for me, that stores this information in one place so that I'm not changing multiple passwords in multiple places, that loads up the JDBC driver maybe statically only once. Maybe every time I ask for a connection, it has this code to actually give me a new connection. So maybe that's a way that I can not repeat myself by creating something called a factory, right? A factory method or a factory class that is responsible for creating other classes. But it's not just as simple as a constructor. It's different than a constructor because for it to work, you have to load up the driver. You have to then make your connection using all of this stuff that doesn't change. So maybe there's a better way I can do this by creating a factory class of some sort. All right. This stuff does change though, right? Select not film ID, director ID, last name and first name, right? From what? Director. Now, if your queries start getting too long, that's fine. You can go ahead and break them up, right? Maybe this is a good place to break them up. Take it to the next line. I don't like the way that it does it by default. I like my pluses at the end, and then I like to align like that, right? So that looks nice. Or maybe even, white space doesn't matter. You can go ahead and indent like this as well, right? So there, by the way, note a little bit different here. I'm selecting the director ID, the first name, and the last name. I'm selecting everything, right? If I go ahead and describe director, or just select everything from the director, I've selected the director ID, the first name, and the last name. I'm just selecting everything. So why do I do this? Why don't I just go ahead and change this to star? Right? That's still bad practice, even if that's what you're doing. Because what happens when next week, a director, we're changing our database so that it's not just a first name and a last name anymore, but a big giant PDF file with film clip, or we add a bunch of film clips to it, right, as a blob, a binary large object. That means I have to go back and change my code now, right? Or if I did it best practices to begin with, I don't have to change it. I don't have to worry about changes to the underlying database that now suddenly insert megabytes of data that I'm not using because I wrote my queries to more intentionally to begin with. Right? So even if you end up selecting everything, it's still a good idea to do it like this. Another good practice is to alias stuff as director ID, because you might end up having a database administrator that designed it all using lower underscore casing, and then you're using it, of course, over here in Java using a lower camel casing, and so that's where aliases can help you. But because I followed that naming convention already, I'm good to go without aliases here. Okay. Prepared statement, result set, exactly the same. Prepare your statement. Now it's a different query, right? Execute query. And by the way, even though it is very, very tempting, I would not suggest that you think, whoa, wait a second. I'm repeating myself a lot, right? The only difference is that query. Might there be a way that I can abstract this all away and like have a generic one-size-fits-all query function? And I've seen people try it, and it just needlessly complicates things. So I would say, in my personal opinion, this is not violating the DRY principle. If you do find this icky, and it is a little bit icky, of repeating a lot of this boilerplate code stuff, that's fine. Instead, use an ORM like JPA, where you're not writing this stuff anyway. You can cut a 10,000 line CRUD application, create, retrieve, update, and destroy, down to a few hundred lines of code, and that's it, when you're using a more sophisticated tool like an ORM. Okay? But you got to learn to walk before you fly, all right? Or walk before you run, I guess. We'll never learn to fly, unfortunately. All right, so it's not like a film ID, it's a director ID. Right? Well, you can buy a ticket, yes, but you're not going to flap your arms and fly. Right? And we don't have title, we have a first name and a last name. All right, and last name. There, now I've got cast name, sorry. And instead of a film, I'll go ahead and create a director. D is equal to new director. Hopefully I have a constructor here. Do I have a constructor? Yep, director ID, first name, last name. So director ID, first name, last name. There we go. And you don't need to save these off as variables if you don't like creating needless variables just so that you can shove them off somewhere else. That's fine. You can go ahead and put the rs.get inside here if you really want to. And then directors.add the, there we go. And then I close my resources. If I can create a factory function for creating connections, maybe I can have a nice convenient method to close them for me so that I don't have to do this stuff all the time. Right? Something to think about. Now in the main here, it's not going to be, let me go ahead and reformat everything. There we go. Director. Oh, and then it's not direct films, it's directors. Done, done. Get all directors. Oops. D and directors. There we go. So what were the directors again? David Lynch, Tim Miller. I didn't put their IDs in here, but I could do that in the toString method. Now the question here is how to connect these two, right? Remember over here in film, I used good composition. I don't have a director ID. A lot of people unfortunately did this, private int director ID, or took this pattern instead. Well, that's what you do in a database, right? That's how you identify, that's a foreign key to the director. But that's not how it works in Java. In Java, you have an object-oriented programming, you have proper composition, that you have a director object. Because what if I want the first name and the last name? Well, that just the ID itself doesn't give me those things. So I'm having I'm using a proper composition here. How might I bring these two things together, right? How might I, instead of just film ID and title, how might I change this query here so that I get all the necessary information? Not just the title of the film and the film ID, but I also want the director information like the first name and the last name and the director ID. How could I change that here? I could write another function, get a director by their ID, right? I could say director ID and then pull out that director ID, int director ID is equal to rs.get director ID, or get int, sorry, director ID, right? And then I can pass that off to a director D is equal to some other function like director.getRecord by ID, right? And then pass in director ID, right? That would be responsible for opening up its own connection, making its own query, and giving it back to you. That's a perfectly fine pattern to use, right? But if I know that I want everything all in one shot, how could I do it differently? Director ID. What else do I want? I want the first name and the last name, right? But those aren't. What if I did this in MySQL Workbench over here? Is this going to work? Select director ID, first name, last name, film ID, a title from film. Now I do need a semicolon. Nope. Why? Director ID, first name and last name are in what part of what table? Not the film table, the director table. What do I need to do if I've got two tables? I need to join them together. So let me go ahead and actually work in MySQL Workbench for now to debug and make sure that I've got the correct query. Right? You don't have to use one tool or the other. You use them side by side. And this is why developers like the dual screen, right? They like having an application up here and an application over here and then going back and forth or something between the two. If you're a web developer, you've got your code over here and then you've got your rendered web page over here taking a look at it, right? You need, as a developer, you need a lot of real estate. And that's why a person I know has actually dual screens, but he's got those panoramic screens, right? The curved screens. So they're super long, and then he's got two of them side by side. So he's got basically almost a semicircle all around him. Really expensive setup, but really cool, right? All right, so let me go ahead and debug this over here. I want the film ID, the title, and the director ID, and the last name and the first name from film. Okay, well, not just from film, but from film. What else? Join director on film. Now here's where I can start using my aliases, right? Film F and director D on f.film ID is equal to D dot, oh sorry, not film ID, director ID is equal to D dot director ID. Right? And it's happy syntactically about that. But what's wrong? Column director ID is ambiguous. It's difficult to read that, but it's complaining, right? Director ID, where is that? That's in two tables. It's a primary key in the director table. It's a foreign key in the film table. Right? So which one do you actually mean? D dot, say. Or it could be F dot. I don't care which one. They're going to be the same because they're foreign keys, right? They could not be. It's not impossible for them not to be the same. But I don't like that name, right? In JDBC, if I go to get this column, what's the column name? It's F dot, right? Director ID. So let me go ahead and alias that as director ID, right? And now this one should work, right? I'm getting the film ID, the title, the director ID, the last name, and the first name. But the director ID, I've aliased that so that I don't have to go D dot, right? Okay? That's a pretty good query. Let me go ahead and cut and paste that. I do not like dark mode over in MySQL Workbench. Right? It inserted end-line characters for me that I'm going to have to take out. So smart cut and paste here is not actually so smart. If you put those end-line characters in there, it probably would complain about it. Right? All right. Now I've got all of those things. How might I change it down here? Well, I'll get the film ID, the title. What else will I get? String, int director ID is equal to rs dot get int for the director ID. Right? And remember, I aliased it so I don't have to remember, did I do D dot or did I do F dot? Doesn't matter because I aliased it. Right? Anything you can do in general encoding to reduce your cognitive load, that is the things that the number of things that you simultaneously have to think about, any time that you can reduce that is very, very good practice, right? Because if there are fewer things that you have to think about at one time, there are fewer failure points, right? Potential failure points. So first name is equal to rs.get string first name. And I've really reduced my cognitive load here by following proper naming conventions, right? They're the same names as in the database. rs.getString, last name. There we go. And now I can create a director and a film out of this. Director D is equal to new director of director ID, first name, last name, right? And now I can pass that on to this and create another different constructor here that takes the film ID, the title, and the director D. Director. And then this dot director is equal to that director. There we go. And let me update also the toString method here. I'll direct by %s and then I'll include the director on this dot director. All right, and let's see if this works. All right, remember I'm doing a big join on this so that I'm getting everything at once so that I can create all my objects at once. All right, and run this. Uh-oh, exception. That's all right. You have an error in your SQL syntax. Blah 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 blah. From film F join director D on blah blah blah. Uh-oh. Maybe I was too liberal in my deletion of stuff. Select blah 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 blah. Last name from film F join director D on. I don't see the issue. I definitely debugged it in the other select. Oh, there we go. Huh. The original was still in there. There, now that's correct. All right. So it was correct. It was just a copy-paste error. There we go. There. Dune 1, directed by David Lynch, or Lynch, David. Deadpool 2, directed by Miller, Tim. And now I've got basically half of my database being loaded up by this one function. If I wanted to, I would have to go back and let's go ahead and describe, show all the tables here. I would have to take care of all the. I'd have to create a film or an actor class, and then if I wanted all the actors in that, it would be a list of actors in the film class, and I would have to join onto that to pull all those records. So you can see that there is arguably, yes, there is a lot of boilerplate kind of stuff going on here. If to do a basic CRUD application, create, retrieve, update, and destroy, you would basically need 4 ways of doing it times however many tables that you have. So if I've got 4 tables and 4 operations that I can perform on each table, I've got 16 different functions that I have to write. Okay? It can get very unwieldy very, very quickly. But that's the consequence of using something lower level like JDBC, where you are doing a lot of boilerplate stuff yourself. The solution is to use an ORM, or like JPA, or Object Relational Modeling, where all you say is that, again, this variable in this class corresponds to that column in that table. You take care of all that for me. It loads it up automatically. It persists it automatically. You don't have to write a single piece of you don't have to write a single piece of SQL code at all. But that's beyond the scope of what we're going to do. Okay, well, the other part of this demonstration was how do we persist film data? Okay, so I'm just going to focus on. You know what? We're gonna. Yeah, I've already got. See, director. Yeah, let's go ahead and put it in here. No, let's go ahead and put it over here. All right, so what I want to do is I want to write another function here to actually persist data. When I say persist, I mean save data to the database. In other words, insert a record into the database. So let me go ahead and write a function that does that. Public, it's void, it's not going to return anything. Insert film, insert new film, right? And it takes a film, F, and I do have to make this static too, right? So given this film that has, these things, the film ID, a title, and a director, we want to insert that into the database. So how much different would that look to selecting things out of the database? Well, again, the driver class, the URL, the password, the user, the creation of the connection, all of that stuff is exactly the same. Again, maybe there's a strong argument here for putting this into a different factory class instead. Part 3, prepare or create my query. Okay, so let's go ahead and create a query here, string Q. How do I insert a record? Let me go ahead and go back to my SQL Workbench here, and let's develop a query to insert a new film record. Okay. Or a new director record if you want to. In fact, let's do the director instead. No. We'll do it like this. Right? We'll just assume that the director already exists. So insert, create, retrieve, update, and destroy, the C of CRUD. Insert into. How do I create a new film? Insert into film. What do you need for a film? You need Well, do you need the film ID? No, it's auto-incremented for you, right? So you do need a title, and what else? Describe film. We've got film ID, which is auto-incremented for us. We've got title. Is it null? It is allowed to be null, unfortunately. Oh, we did not allow. Oh, that's okay. We made Internet Movie Database ratings here non-nullable, but that's okay because we made it a default value, so it'll just get a rating of 5. Likewise, the EIDR. That's actually required, and so we will have to put that in. That's something I did not do yet. So we'll just make something up, right? And then the director ID, right? The director ID is not allowed to be null. Why? There is a one-to-many relationship between the director table and the film table, meaning that you've got a parent-child relationship here. The parent has to exist before the children can exist. So you have to put in the director ID. So let me go ahead and make a minimal here, a minimal query, EIDR. Right? Now I'm regretting designing it like that, at least for demonstration purposes, and director ID. Values, oops, we'll go uppercase here, values. Well, if I were to insert another, I don't know, Eraserhead. I forget if it's one word. I'll assume it's one word. That's another film of David Lynch's. If we look at David Lynch here, he has a director ID of 10, right? So Eraserhead, I have no idea what the EIDR is. I'll just make something up, foo. And then 10, right? Now, if I were to run this query, it would insert that new film, right? I'm not going to do that because I want to do that through JDBC. But that is the basic query. It's syntactically correct. Come on. It's syntactically correct, so I'll go ahead and cut and paste that over here for my query. Oops. It's not copy, paste. Nope, it's not. There we go. Copy, paste. I'm regretting dark mode now. I'm just not used to it. Maybe I hope, but there we go. Okay. Is that always going to work? Is that a good design? Always insert Eraserhead by David Lynch? No. What I actually want to insert is the film's F's title, F's director ID, and F's EIDR, right? For the EIDR, I'll just make something up, right? So I need to make these. I need to make these things in this string. I need to make these variables. The way that I do that in JDBC is I don't know what they stand. I don't know what the values are. So question mark. I don't know. And I don't know if they're strings or numbers either. I let JDBC take care of that for me. What is it? What is it? What is it? I don't know. There are just 3 things here. Okay. So that is my query. Right. There is no result set because if I'm inserting into the database, I'm not expecting to get anything out. A select statement returns result sets, but I still use a prepared statement. And I need to prepare it. Try. PS is equal to con dot prepare statement of Q. Right? Now, the statement is prepared, but what about these values right here? Those are still unknown. I have to set those values now. Okay? So PS dot set. Well, what's the first one? The first one is a title. So I'll set the string of now parameter indexing here. Which one do you want to set? The first one, the second one, or the third one? Normally in computer science, everything is 0 indexed, right? This is another failing of JDBC. It's not 0 indexed. The first parameter, this first question mark right here, is index 1. Right? So that is a bit different than what you're used to. And by the way, that's something that JPA fixed. You don't want to deal with index. In practice, you don't want to deal with indexes either. Because what if I come in here and I decide, oh, I do want something else. So another question mark. Now I've got 4 parameters. Well, wherever I inserted that, now everything is going to have to be bumped down, right? I'm going to have to recount everything. It's much better to have what are called named parameters. A named parameter would look something like this. Title, with a colon in front of it. That's a named parameter. Unfortunately, JDBC does not support that. JPA does. Right? So we're still stuck doing this. Well, what do you want to replace the title with? F dot title, right? Or the getter F dot get title. Right? I don't have any getters here, so I'll just go with title. Right? What about the second one? The second one is the EIDR, so it's ps.set string of the second one, and I'll just make it up, foo, all right, 1, 2, 3. Right? And the third one, ps.set, well, that's not a string, right? That's an integer, so set int of the third parameter, f dot director, and the director has a director ID, right? And there I do have getters. Okay. Once all of that is prepared, I need to execute that statement. But since it's changing the values in the database, it's inserting values. I don't use execute query. I use execute update. There we go. Now, it's still an insert. It's not an update. Remember CRUD, create, retrieve, update, and destroy. Insert, select, update, and delete, right? Delete, update, and insert, they're all considered the same thing. They're changing the database, so you use execute update. Right? It does not return a result set. It returns, if you read the documentation here, it returns either 1, the row count for the SQL database manipulation language, blah, 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 or 0 for SQL statements that return nothing. Right? So I think that it's basically like a flag. The row count, how many, if you do an update, it returns how many rows were updated. If it doesn't insert, it might return 1 or it might return 0 because it doesn't return a value. I don't remember, right? But it's not that useful anyway. Let's go ahead and catch this. Right? And what should I do am I done now? What's the last thing you should always do? Close your stuff, right? Close your resources. I'll put a fourth exclamation point if you need it. Right? Close your resources, otherwise you will run out of them. Now in this case, I did not have a result set, so I don't need that, but I do have a prepared statement. I do have a connection. Right? I've closed everything, and now it should work. Right? Execute update. Let's see if it works. Let me go ahead and, I need to actually write some code to do this first, though. So film f is equal to new film. I need eraser head, and what else do I need for the film? I need I need the ID. Okay, to create it, I need an ID. So maybe I want another constructor here where ID is optional, but the title and the director are not. So I don't care. This dot director is equal to director. There we go. So eraser head and a new director. And I'll just hard code it for this one. David Lynch. There we go. But of course, I would need to go back and write my own CRUD for the director as well. Remember, if you've got 4 operations, create, retrieve, update, and destroy, and you've got 4 tables, you're essentially writing 16 different methods if you're going to do all of this boilerplate yourself. Okay? And then once I've got the film, I need to go ahead and, film dot insert film, F. There we go. Or eraser head, EH. And then so this will insert the film. Then when I go to get all the films, I should now see that new film as part of my database, assuming everything is correct. There we go. So eraser head directed by David Lynch, David. What do you think would happen if I ran this a second time? If I run this again and it tries to insert a duplicate eraser head record. Do you remember over here? What did we do with the film? The EIDR, we made that unique. So if I try to insert it with foo123 for another record, should that happen or should that not happen? Should not happen, right? Because I don't want 2 films with the same EIDR, right? So let's go ahead and see what happens. Exception. Why? duplicate entry foo123 for the unique EDIDR, whatever, right? This results in a runtime exception. It's actually a SQL integrity constraint violation, which is some sort of a SQL error. Ultimately, it's just going to be an SQL exception. And where was it actually generated? On there, on that execute update, right? It was caught as an SQL exception and rethrown as a runtime exception, which makes it appear right here, right? So if there are any problems, syntax errors, constraint violation errors, a child constraint fails because you try to insert a film without a proper director, and that will fail because you try to insert the child before the parent existed. Those will all just be generic SQL exceptions that you rethrow as runtime exceptions. You go back to the drawing board. How did I not write my boilerplate CRUD here to take care of that? Right? Any questions so far?
So,
yeah, go ahead.
When you create the prepare statement for the insert, the set string, setting, etc., is what makes it safe as opposed
Yes.
to making like a format string.
Right. For example, what if the title was not Eraserhead by David Lynch? It was, I don't know, David or Lynch, David O'Halloran. Uh-oh. What about this thing right here? That has to be escaped, right? Well, if you want to, you can go ahead and write your own escape code, or you can just let, you can do something like this. Actually, what you would need to do is this, because you want the backslash, and so to get the backslash, you need 2 backslashes. But don't worry about that. JDBC takes care of it for you. It escapes it, okay? And we will talk about SQL injection attacks next time, exactly why you would want to do this. I'm not even going to bother to show you unprepared statements, because you should never use them, right? Any questions? All right, we'll pick it up there next time then.